Hello, good morning and welcome to this channel. If you are writing JAMB this year and physics is part of the subjects you will write, listen to me now. I'm going to show you something very important if you aim at scoring high. Now, I will show you something, I will show you some questions that you should just try as much as possible to master them. Don't joke with these questions. I've checked JAMB past questions over the year and I have found it to be a pattern. Every year you must see questions from this place. Now I'm going to explain it to you clearly and I'm going to show you some questions that you will go and practice by yourself. But before now, let me ask you this. Take a look at these questions. Yeah, first question says, if a plastic rod is rubbed with wool, what type of charge does the rod gain? Can you answer this question? Okay, don't bother, don't worry. I'm going to explain all these things clearly, including the calculations. See, questions under electrostatics are inevitable. So prepare yourself now to be able to address these questions. Yes. Look at question 2 now. Look at the second question. Which of the following is a conductor? Plastic, rubber, copper, glass? Oh, maybe you know this. It may look very simple. Yeah, you may know this. But look at question 3. Two charges, 5 Coulomb and -3 Coulomb, are placed 2 meters apart. Find the force between them. Can you answer this? Okay, don't worry. Now, you need to know this. I'm telling you. See, calculation questions are very, very simple, especially in physics. All you need to know your formula, know the law you are dealing with, know the rule you should apply. Simple. So don't get low mark in physics because you just neglect these small things. Please, I beg you, stick to this video and watch it till the end. Try the questions I'm going to give you. See, they are very simple. By the time I'm done explaining, you'll find out that they are very, very simple. And so stick with me on this video. Just be patient. Whatever you have to attend, just be patient. Devote this small time and know this thing once and for all. Once you understand it, you may not need to be watching this video again. All you need to do is write out the formulas. Make sure you memorize them very, very well. And that's all. That's all. See, preparing for exams is very simple if you are smart. Please, let's go on. I don't want to waste much time. Alright, now this aspect of physics we call electrostatics and electricity. Like I said earlier, you cannot escape question from this place. So the best thing is to try and know it. And knowing it is something very simple. It's very simple. Okay, so let's start with electric charge. What is electric charge? Electric charge is a fundamental property of matter. We have negative and positive. So these are electric charges that we have. Why should you know this? JAMB can ask. Electric charge can be defined as A dash B dash C dash D dash. Do you get what I'm trying to say? They want to assess whether you know what electric charge means. And mind you, I have checked the syllables. I have discovered what these people are after. You see, just if you can know the objectives that should be achieved under each topic, you predict the question you'll be asked. This is what I've been telling my students. I told them that, you see, if you are smart in exams, you can predict questions that will come out. Now, one of the objectives is that students should be able to understand the basics of electrostatics. And part of the basics is to be able to define what an electric charge is. Alright, let's go on. Now, we have what we call conductors. We have what we call insulators. Conductors are those substances or materials that allow the flow of electricity through them. You know this now. It's too simple. It's too basic. Just remember. All metals are conductors. If I take you now back, you'll be able to answer that question, even though some of you, I know you have already known that before. Insulators does not conduct electricity. Example of insulators are plastics, wood. They don't conduct electricity. But if you have copper, aluminium, in fact, all metals are good conductors of electricity. So you should know this. This is basic. This is basic. This is basic. All right. Now, this is the fundamental law of electricity. Now, know this now. I beg you. In the name of God, I beg you. Like charges repel, unlike charges attract. If you understand this simple law, many problems in chemistry and in physics are solved for you. Do you know that reactions in chemistry are based on this law? Do you remember your anion and cation? So is this simple? Is this basic rule of electrostatics? Please know it is the fundamental law of electrostatics. Charges that are similar, they don't like each other, they repel. Charges that are opposite, they like each other, they come together, they attract. This is very simple. I hope you are getting this. Like charges repel. Positive and positive, they do like this. Negative and negative, they do like this. But negative and positive, they attract. Is this clear? If you forget never forget this law in life. If you are a science student, this is a must-know law when you are dealing with electricity, electrostatics, and reactions generally. Okay, we have a scientist that came up with a law, and let me advise you, if you know these small laws, most questions come from here. Either you'll be asked to state the law, or they will ask you which of the following is the mathematical expression of Coulomb's law. Yeah, I've seen questions like this. So they will write different mathematical expressions, different formulas, and ask you which one is for Coulomb's law. So if you know these laws, it will be very helpful to you. Now, what is Coulomb's law? What is he saying? See, I have mastered this law since from my secondary school, and I've never forgotten it, even till today. Now, let me show you the trick I used to master it. Look at this formula. Are you seeing the formula there? F is equal to K, Q1, Q2 over R square. Now, how did I master this law? I memorized the formula. Now, I don't need to know that Coulomb's law states that the force of attraction or repulsion between two charges is directly proportional to the product of the two charges and inversely proportional to the square distance. Do you know that this is the law? And how am I stating it? I didn't master it. I didn't memorize it during my secondary school. I'm using this formula now to make this statement. Simple. If F is equal to A, for example, it means that F is directly proportional to A. If F is equal to 1 over A, it means that F is inversely proportional to A. See, just understand this trick. So with this formula now, because I have memorized it right since secondary school, I have understood it. I'm using it now to just say the English. Simple. F stands for force, Forget about K. K is a constant of proportionality. See, if you have done proportionality, you know what I'm talking about. If you don't, please write in the comment section, because you must understand this thing. Write in the comment section. Maybe I'll create another video explaining these things in details, because you must know this. If you know it, you'll be able to master many laws just to knowing their formulas. And that's my own strategy. And it helped a lot. It saves time. You don't have a lot of time to be memorizing English. No. But once you master the formula, you can set any law. Let me tell you, as we continue, you would see that I will just be stating the laws. I'm using formulas so to state them. I have mastered the formulas, and anywhere I see them, I will just put English together. Please master this. Let me state it again. The force of attraction between two charges, the Q stand for charges, the R stand for distance. So look at the force, that's F. The force between two charges, Q1, Q2, is directly proportional to the product of the two charges. Do you see that Q1 and Q2 are multiplying themselves? Yes, now. So is the product directly proportional to the product of the two charges. And inversely, because R is now under, that's inverse proportion, inversely proportional to the square distance. I hope you get this, please. If it is not clear, the comment section is there for you. Reach out to me, understand this thing, I beg you. I don't want a situation where you go to JAMB and see this thing and cannot answer it. By the way, I'm out to achieve a mission. I want many students to have a minimum of 250 in this year's JAMB. If your target is 300, you are part of the people I'm targeting. I'm out there to support. So please understand it. Now, K is a constant of proportionality, and a constant is always a constant. So K is equal to 9.0 times 10 raised to power 9 Newton per meter square per Coulomb square. So this is very important for you to know. The formula, the constant doesn't change. It remains the same. Now, let me a little bit explain this thing in layman language so that you understand what Coulomb is trying to say. Now, this man's law is talking about there is force of attraction all the time, or force of repulsion. There is shear force between two charges, and this law has even been further, emphasized by one scientist again under gravitational field, where they are talking about there is always force between two objects. So between you and book, there is force of attraction. You see, it looks like crazy. Like, how do you say that the book is trying to attract me, or I'm trying to attract a book? Yeah. These laws have been proven. The only thing is that the force of attraction might be negligible. What do you mean by that? Very, very small, such that you cannot even feel it. So this means that even if you are walking between two cars, there is force of attraction between you and the cars. Yeah. But the force may be very, very small to stop you from moving, or for you to feel attracted. The force is very small. I hope this is clear. Please note this. Thank you. Let's move on, please. Yeah. How many of you have seen question under this before? JAMB, WAEC, NECO. How many of you have seen this question? This is what we call gold leaf electroscope. Now, I will advise you to go and learn how to label it. I supposed to have put a picture with the label, but it's not a problem. It's not a problem. You don't have many things here to label. I don't know. I wish if I tell you, you can understand. So we have the glass container. where you are seeing, look at the image A now. That's why I'm explaining. Look at the image A. Where you are seeing charges plus plus, those two that you are seeing like this, that's what we call the gold leaf. The gold leaf. Then at the top, that's the metal strip. You may see another name for it somewhere, but metal strip, that's the top that you are seeing there. Then if you come down, you see one triangle, I say triangle, rectangle, through which the conductor passes. So that is an insulator. It is an insulator, so it can be any material. So this is just the basic labels that you should know, because don't be surprised to see it in JAMB and they'll say the part labeled Roman number 1 is referred to as gold leaf, jar, metal strip, and so on. So you need to know these basics. All right, what is this instrument used for? This instrument is used to test the type of charges an object carries, and I want you to understand this principle. I'm going to show you questions, so I'm going to show you questions like real JAMB questions. I will show you under this so that you will know that I'm not just out here to waste your time. Even when I say be patient and just watch this video till the end, you will know. All right, so now let's go to the second image and let me explain how this thing works. Now, if you bring an object that is positively charged and put it on the metal strip as you are seeing in image labeled B, if the charge of the gold leaf electroscope is similar with the charge of the object you brought to it, the leaves will diverge, that is, they will open. Do you get my explanation? The object you are bringing is positively charged. The electroscope is positively charged. So once you place the positively charged object on that metal strip, the gold leaf inside the bottle, these two strips, will diverge. What is this saying? You are bringing like charges together now. And what is the rule? The fundamental rule of electrostatics: like charges repel, they go their way. So do you see, as you are bringing a positively charged object, the gold leaf is diverging. Opposite is the case when you bring opposite charges. If the gold leaf electroscope is positively charged and you bring a negatively charged object, remember we say unlike charges attract. So this is how gold leaf electroscope work. So if you bring an object and you don't know the kind of charges it carries, just place it on the gold leaf electroscope. If you see divergence of the gold leaf, then it means the object you brought has similar charge with the electroscope. If it converge, it means they have negative charges. Please note this, I beg you. Let's quickly go. All right, if you have not liked, if you have not subscribed to this channel, I have students I'm training. So if you are my returning student, like this video and comment on this video. You know why? I have told you guys that I am out for a mission 250 students to 250 and above marks in JAMB this year. So far, in the two groups I have, 3 WhatsApp groups that we have, I have roughly, let's say, 200 students in total. So I still need to reach out to more. And the comments you guys have been making and the likes you have been liking, you know, it has been attracting many more students, serious ones, who have been joining our WhatsApp group. Yeah, you are aware that we have 2 groups. Yes, so I need to still reach more students, more. And the only way this video can go more is when you share it, when you like it, when you comment on it. It shows YouTube that this thing is relevant and they will show it to many students. So if you have not subscribed, subscribe. I have many videos on this channel addressing JAMB issues, past questions, and so on and so forth. You can have access to them, and if I post any new video, you'll be among the first to know if you set the notification button on. So please subscribe and let me be able to reach as many as students as possible. We have a very short period of time. Yeah, 25th of April, God willing. It's not far. Thank you. Let's go. All right. This is a calculation question under Coulomb's law. Now, we have stated the formula before. Can you still remember the formula offhand? Yes. F, that's force of attraction, is equal to the product of the two charges, that's Q1 Q times Q2, and inversely proportional to the square distance, that is all over R square. Don't forget your K, constant. K should be along with Q. That's the formula, don't forget it. Alright, so we have a question here that says two charges, 5 Coulomb and minus 3 Coulomb, are placed 2 meters apart. Find the force between them. Now, your distance should always be in meter. If it is given in centimeters, change it to meters. If it is given in kilometers, change it to meter. Remember, the video I made on SI unit, yes, Standard International Unit, I said the SI unit of distance is what? Meter. Don't forget that. So you change it to meters before you continue your calculation. Alright, so you see how simple it is now. What do? All you need to do, substitute the values in your formula. Simple. Now, what is our K? I said K is constant. This number does not change for K. It is always the same. And you see it there, 9.0 times 10 raised to the power 9 multiplied by, see our Q1, 5, multiplied by, see our Q2 minus 3, all over our R is what? 2 meters. But remember, in the formula, R has square, so it will be 2 square. Is there anything difficult with this? And these are the questions you should expect too. Alright. So multiplying, if I say, remember in one of the videos I made, I said, anytime you encounter operations, mathematical operations that involve standard form, collect the like terms. Simple. Those that doesn't have raised to power, multiply or add them together depending on the operation. And this is what I did here. 9.0 times 5 times minus 3, that is what gives minus 135 times 9 raised to power times 10 raised to power 9, all over 2 square is 4. So now if you divide 135 divided by 4, that will give you about 33.75 times 10 raised to power 9. But then 33 is up to 10, so if I raise it to standard, that will give me 3.375 times 10 raised to power 9. If you don't know how to work with powers, please let me know so that I can create a video on that. Now the negative sign means the force is attractive. Is a force of attraction or attractive force. If the answer is positive, repulsion. So I hope this is clear. Now this is your first assignment question. Two charges, 2 Coulomb and 4 Coulomb, are placed 3 meters apart. Find the force between them. This is your first assignment question, number 1 assignment question. So write it out and do it, work it. This is number 1. There are other questions that are coming that you do. If you are not my student, see, I have a group of students I'm training already, and we have WhatsApp channels. We learn in diverse ways. So if you are not part of them, and would want to be part of us, just put in the comment section, I'm interested in being part of the your students. I will find a way to add you to our group. Thank you. Okay, next on the list here is electric field. Electric field. What is electric field? Electric field is a region around a charged object where another charge experiences a force. See, don't neglect these definitions, please. Know them. Know them. A region around a charged object where another charge experiences a force. It's simple now. Just understand the clip. See, JAMB is very simple because it's objective question. You don't need to write English. Just know. No. Because you may be asked, there is many ways to ask for this definition. I've given an example earlier with electrostatics now. By the way, what is electrostatic? The study of charges at rest. Please note that. I think I gave an example of one definition. Alright, so to calculate electric field, you have E is equal to F over Q. This is simple and straightforward. Force over charge, that's electric field. Force over charge, that's electric field. So we have an example, a worked example there. Say a charge of 4 Coulomb experience a force of 12 Newton in an electric field. Find the field strength. That's find the electric field. And that's simple. Force over charge. That's 12 over 4. This is very simple. Here comes your second assignment question. Question 2, which says a charge of 5 Coulomb experiences a force of 25 Newton. Find the electric field strength. This is your assignment question number 2. If you are not my student, you can still do the assignment too. Do the assignment. Just find a way of connecting. Just tell me I'm interested. I will respond to you as soon as I can. Share the WhatsApp link so that you can join to be able to submit your assignment to me. Thank you. Alright, then. Oh, here we have capacitance. What is a capacitor, by the way? What is a capacitor? A capacitor is a device that can store electric charges. It's a device that can store electric charges. Many of us knows them. Look at that picture. Have you not been seeing these kind of things before? In a radio, if they open television, even in remotes, you might have been seeing this. On our phones too have capacitor. I remember that olden day phone, Nokia. You know, if you off Nokia phone, okay, and you on it back, sometimes you find out that the time remains correct despite the fact that there is no network. You know, Nokia is not like Android now. Android set time with network. But this one doesn't set time with network. So it has capacitor. That capacitor stores charges. So while the phone is off, the charges are enough to keep your time correct. Yeah. So a capacitor is a device that stores electric charge. Now the ability for every system to store an electric charge is referred to as capacitance. Capacitor is a device. Capacitance is the ability. Know the difference. So they are not the same thing. So that you not confuse anything. I am sure you'll be asked definition, and that's how you'll be asked. The ability of a system to store electric charge is referred to as dash. Capacitance. A device that has ability to store or a device that can store electric charges is referred to as dash. Do you see it? So, how do you calculate capacitance? The formula is C, that's capacitance, is equal to Q over V, that's charge over voltage. This is also very simple. The formula is just too simple to remember. So, and with this formula, you can calculate the charge. If you are given capacitance and voltage, can't you? Cross multiply to make Q the subject of formula. And you can calculate voltage also from this formula. Make V the subject of formula. isn't it? Alright, look at the worked example. A capacitor stored a charge of 6 coulomb at 3 volts. Find the capacitance. Very simple. Okay, then comes your number 3 question for assignment. Work this out, find the correct answer, and write it. Now, this is what you do. Just write question 1. If your correct answer from your calculation is A, write A. Question 2, C. Question 3, D, in that order. I hope this is clear. Alright, so let's go. Okay, so here we have energy stored in a capacitor. So what's the formula for calculating energy stored in a capacitor? The formula is U, which is energy, is equal to half. Now you say, how is U energy? Please, we are dealing with electricity here, so we are not talking about the normal what do we call it, under motion. We are not talking about energy under motion and others. So here energy is represented by a symbol U. So the formula for calculating energy stored in a capacitor is U is equal to half CV square. Half CV square. And C stands for capacitance. And capacitance is measured in farads, please. And voltage, of course, in volts. So you know that. Okay, so we have a worked example there also. A capacitor of 4 farad is charged to 10 volts. Find the energy stored. So you can see half times 4 times 10 raised to power 2 because V is already squared in our formula. And that gives us 200 joule. Don't forget, joule is the unit for measuring energy, and it is used here even in electricity as it is. The only thing we have a difference here is the U, which serves as the symbol here for energy under this. Then comes your question number 4 assignment. A capacitor of 2 farad is charged to 5 volts. Find the energy stored. Work this out, get the correct answer, write it, and submit it. Okay, then we have Ohm's law. Yeah, many questions come under Ohm's law again and again. I have observed it. It's more like a trend. And if you understand Ohm's law very well, there is no question they will ask you that you cannot answer. So now, let me use formula also to state Ohm's law. So V is equal to IR. Do you see that? So it means voltage is directly proportional to what? To resistance, provided that current is constant. Current is the constant of the proportionality now. So V is proportional to R. That's the law. V is proportional to R. So, and V is for voltage, I is for current, R is for resistance. So the formula is also very simple. You can calculate current using it. If you are given resistance and voltage, you can calculate resistance if you are given voltage and current, and so on and so forth. Just manipulate the formula, make the subject of formula what you are looking for, and you do your calculation. That's all. So you have question 5 for your assignment. Question 5 for your assignment. A 40 ohms resistor carries a current of 5 ampere. Find the voltage. So work that out and choose the correct answer. Okay, then we have Kirchhoff's law. Yeah, this is another law. Kirchhoff says total current entering a junction is equal to the total current leaving the junction. This law is very important too. You must not forget it, and it can easily be asked. Very easy. So if we have a junction, okay, yeah, look at this image. Look at the image here in green. It has a clear explanation. Look at 2 arrows. They enter a junction. There is where they meet. So that represents current. Current coming into a junction is equal to the current going out of the junction. Look at the arrows, how they enter and the ones that went out. So we have current 1 plus current 2 is equal to current 3 plus current 4. That is, the total current entering a junction is equal to the total current leaving the junction. That's just a simple rule he said. So if now, for example, they say I1 is 5, I2 is 4. That's current, the two current entering the junction. I1 is 5, I2 is 4. What's the total current? 9, right? Okay, so they now say I3. I3 is 3. What is I4? Can't you calculate that? You know that 9 has entered, so 9 must go out. But they now give you 3. So what is remaining to make it 9? 6. So it's as simple as that. So the formula is there. I1 plus I2 is equal to I3 plus I4. Simple. I've not given any example on that, but it's as simple as that. Another thing that Kirchhoff says is that the sum of voltage in a closed loop is equal to 0. You see, they like asking these inner questions, inside questions. So no, it's when we mean what we mean by a loop is more like it enters into a cycle. So if the voltage in a cycle, the sum total is always equal to 0. I have an image there that indicates that. So if you have a voltage in a loop, the sum total is equal to 0. It's a simple rule that you should know. I have one worked example there. In a parallel cycle, resistors of 2 ohms, 3 ohms, and 6 ohms are connected. Find the total resistance. So this is part of the law, but here we are calculating resistance, and the formula is 1 over R is equal to 1 over R1, 1 over R2, 1 over R3 in that order, because we have parallel circuit connection. So that's how you would calculate that. So the first one has 2, 3, and 6. So 1 over R is equal to 1 over 2 plus 1 over 3 plus 1 over 6. All you need to do mathematics. Find the LCM of 2, 3, and 6. You know how to work this out now. So take the LCM. The LCM is 6 at this time around. So when you calculate everything, your answer would be 1 for this question. Now, follow the same example and work your assignment number 6. Thank you. All right. This video is already becoming long, and I would like us to. Okay, let me just be fast as possible. I think I'm almost done. This will be the last, if not, yeah, should be the last. Okay, so we have electric power. Electric power can also be calculated. So, and what is electric power? Electric power is the rate at which electric energy is transferred or is converted in an electric circuit. You know, sometimes we have low voltage, we have low current. No, we don't have, we have low current actually, but you cannot detect low current. You can only detect low voltage through appliances. If the bulb is not bright enough, that's low voltage. Yeah, so you can detect it. If the fan is not moving fast, that's low voltage, you can detect it, but you cannot detect low current. Low current need devices. You cannot see it by appliances that convert the electricity. But when we talk about power, we talk about the energy that is the rate at which energy is transferred or converted in an electric circuit. So the formula for calculating electric power is P equal to VI. P equal to VI. Do you see that this is also simple? Do you remember Ohm's law? V is equal to what? IR. Don't forget this formula. So here we have P is equal to VI. Now, you may be asked to calculate current, you may be asked to calculate power, you may be asked to calculate voltage from this one formula. So the worked example here, I have given power. Look at it, worked example. A 100 watt bulb operates on 220 volt. Find the current drawn. So, and this is very simple. Just make I, which is representing current, the subject of formula, then calculate, divide. and that's all. So follow the same pattern to do exercise or assignment number 7. Follow the same method. All right, thank you everyone. Please and please, I urge you, do your assignment and submit. Okay, what time should be the deadline for the submission? Okay, should we do it as usual? 8:30 p.m. before 8:30 p.m. Okay, now since I don't know when you'll be coming across this video, just do it and send it to me. If you are my student, you know how we submit it, to my DM. Don't drop it in the group. If you are not my student, you have to be in the group first before you can see my number and be able to submit. So if you're not my student, please don't drop your answers in comment section. Some people might come and see them and copy. No, find a way. Just tell me in the comment section that, sir, I'm interested, and then I will send you the WhatsApp link. Then you join immediately. Once you join, you'll be able to submit your assignment. I will mark it and give you feedback. I urge you, JAMB candidates, don't play with this area of electricity. I did not even cover all. I cannot cover all now. So maybe in the next video I will try and see what I can do. I have done video on waves, I've done video on motions, I've done videos on several other. Just go click the channel and scroll through. You would see. In fact, I've even helped arrange them in playlists. For physics, I've put the videos together. For chemistry, I put the videos together. For biology, I put the videos together. So follow these things. I know what I'm doing. I know what I'm doing. I have written JAMB, I've helped many write, and I know what works, and that's what exactly I'm giving you. To my students, thank you for care, thank you for your messages, private and calls. Thank you so much. My journey went well. I returned safely. Thank you for your care, and please, we are back on board. I told you last time that once I'm back, it is going to be back to back because there is no time. So let's see how we use the little time that is left for us to push. We have a target. The target is 250 plus 250 and above. So let's work on that. Please continue to cooperate with me. Once I say assignment, kindly create time to work. See, if you cannot create time to work this, don't think that you are planning for where we are going to. That's just the truth. I have said again and again how consistency helps. So just be consistent. It mustn't have to be long hours of reading. See, if you can dedicate 1 hour, even if you are starting preparing for JAMB today and can dedicate 1 hour per day, I tell you, it will change your score dramatically. That's just the fact. And that's the secret to success: consistency. If you are consistent at anything, you become good at it in no time. So please be consistent. Lastly, please, I want feedback. Are you learning? Are my explanations clear? Am I fast? Should I be slow? I need your feedback. Please, whether you are a returning student or you are just coming across this video for the first time, please let me know so that I will know where to adjust. If I'm fast, say, sir, sorry, you are fast. I'm not getting some things. If my explanation is not clear enough, because sometimes, I I used to find myself teaching different categories of students, university students. In fact, there was a time that I taught primary school students. So, and there is difference. Sometimes if you are, the way you teach handle university students is not the way you handle primary school students. You may have to do a layman explanation, as in you have to be basic. So if maybe I'm using the university student approach too, you may not be able to get along. So just give me feedback, I beg you. Don't watch this video. If you have watched this video till the end, I salute you. You have something that is very important, and that thing is should I call it resilience? Should I call it, I will not call it consistency, because consistency has to do with you doing it again and again. But let me say you have patience. Many people will watch it 3 minutes and they will go. And they will think by that they are learning. It cannot be possible. If you cannot devote your time to learn. So please, I want to see your comments. Thank you very much. God bless you. Do have a wonderful day. Bye.